Alright, so in the last video, we got our environment set up. So now we're going to come over here to our terminal, where you got this little blinking cursor, and we're going to start talking about some of the tools that we need to program. Now in this particular video, we're going to talk about arithmetic operators. And as you might have already guessed from the name arithmetic, it's your simple things that you probably learned from kindergarten on up. Your addition, your plus sign, subtraction, your minus sign, multiplication, your multiplication sign, division, division sign. We also have something called modulo, which gives us the remainder of a division problem, and explanation, which is your exponents, like if you raise something to a certain power. So let's start with the simple one. It's just 5 plus 3, addition. So if I type that in, hit enter, I get 8. Now the one thing to know about this plus sign here is we use it for addition, but later on down the road, when we start working with strings and something that they call concatenation, which is where you join strings and variables together, they also use this. So this is going to become a little bit of a headache, but once you learn all the techniques to figure out what to do, it's actually pretty easy. But when adding two numbers together, it will produce the correct results. And as you can see, it's the same one that I've used in school, and I'm like 60 years old almost. All right, so the next one we're going to talk about is subtraction, or the minus symbol, and we'll just take 5 and subtract 3, or 5 minus 3, and of course that'll give us 2. All right, so there shouldn't be any questions here. Next one is multiplication. We'll just take 5 times 3. Now this one may look a little different. We used to use an X or a dot when I was in school. Here they use an asterisk, which is the shift and then the 8 key at the top of your keyboard. And that's how they do multiplication. So we hit enter and we get 15. Now if we take that 15 and divide it by 3, and once again this isn't the same division symbol that I used as a kid, but this is the way they use it in computer science, and it's just a forward slash, which is at the lower right hand side of the keyboard on the same key as the question mark, right next to the shift key. Now Python has two ways of dividing. This will give me a decimal number. All right, because a lot of your division problems are going to calculate out to a decimal number unless it's even. Now this one happens to be even, it'll be 5, but it's still going to give us a decimal number, and it gives us 5.0. Now you'll see later when dividing, computers aren't as good as we'd like them to be, because a lot of times straggling way out past the decimal mark are some additional numbers that if you don't get rid of them, they could come back to haunt you later, because your calculations won't come out the way you want them. And once again, you'll see this down the road. So to alleviate that here, Python has a way of dividing just by doing a double division sign here, and that will force it to an integer. So by doing this, 15 and then 2 forward slashes, then 3, now we should just get the number 5, and that is an integer. Alright, so let me go ahead and clear this screen. And you do that just by typing clear, and as you can see we're on line 6 right now. And that brings us to line 7. So we've gone through addition, subtraction, multiplication, and division. Two types of division. One to get a decimal back, also known as a float in computer science, and one to get an integer back. So the next thing I want to talk about is something called modulo. And what modulo gives you is the remainder of a division problem. So if we did 17 divided by 3, for example, and if I run that, of course, I'm going to get a decimal number back, or a float. And it gives me 5 point, a bunch of 6's, and then a 7 way out on the end. And that equates to approximately 5 2/3. So just by knowing that, you know that the remainder is going to be 2/3. So you'll also notice that this is above 5.5. So when we do the 17 double division signs 3 to get an integer back, it doesn't round it to the closest number. It takes it back to the base number. Alright, so we got 17, and then the double division sign 3 gives us 5. So if we want the remainder of that, we use modulo. And modulo is the percent sign. So it'll look just like this up here, but this will be the percent sign. Alright, and the percent sign is located if you hit shift and then the 5 key at the top of the keyboard. That's where the percent sign is. You hit enter, and 17 divided by 3 is 5 with a remainder of 2. Now modulo is a very important operator that you're going to use a ton of times in upcoming problems that we're going to solve. And I'm going to take you through one of them right now, which is giving back change, finding out how many quarters, dimes, nickels, and pennies are in, say, $4.36. So the first thing I'm going to do is go ahead and clear this. And I'm going to go ahead and set up my counters for these things. So I'm going to take Q for quarters and set that equal to 0. And I'm going to do the same thing with dimes, nickels, and pennies. So D, N, and P. And then the money, so we'll just call that M. We'll set that equal to, and I'm thinking $4.43. So 4.43. Alright, so if I call any of these back, it'll give me its value, and I'm just going to do that by calling M, and as you can see I get $4.43. Now one of the things that I've learned over the years is anytime you can avoid working with a decimal, get rid of it. So this is a decimal right now, and if I wanted to make it an integer, all I would have to do is multiply it by 100 and then do something called casting, which is forcing it to an integer. Now we'll get into casting down the road. I'm going to do a quick thing here just so that we change this to an integer. But I can set M equal to int. Alright, that's how you cast it. So basically anything that I calculate in here is going to become an int, and I'm assigning it to m, which is currently 4.43. So I'm going to take m times 100 Alright, and when I do, that should give me 443. So let me go ahead and run this. And now if I call m, it should have been cast to 443. And it has. Alright, so what did I do here? I've still got all these quarters, dimes, nickels, pennies that I haven't done anything to yet. And what we're going to do is we're going to figure out how much is in each one of those. And then we're going to assign the value to those variables. So I've taken m, which is $4.43, multiplied it by 100, so I'm working with an integer now. So 25 cents, which would be 0.25, now it becomes just 25 because you have to multiply that by 100 as well. So let me clear this screen. Let me call my money, see how much I got in there. 443. So now I'm going to set Q equal to 443 divided by 25. And remember, we want an integer back because we want to know how many quarters. We don't want to, there's no such thing technically as a partial quarter. So now if I run this and I check Q, it tells me 17. Well, we know there's 4 quarters in a dollar, and 4 times 4, all right, because we had $4 to start with, is 16. And then we got another one, 25. We'd have to have 2 if it was 50 cents or more. But since there's only 1 after there, that gives us 17. So now we need to figure out a way to calculate the remaining money, and this is where modulo comes in. So I'm going to set R, which is a remainder, and it's going to be 443 modulo 25. And if you look at this, all right, it's almost got the division sign in there, but once again it's the percent sign, which is Shift 5 on the keyboard. So 443 modulo 25 should be the remainder. So we're at 425 with 17. So if we hit enter and check R, we see that there's 18 cents. So if you count that out, 25, 35 plus another 8, so that's 18 left over. So now we're not thinking about money anymore, okay? We're not going to mess with that. We're going to mess with the remainder. So let me go ahead and clear this screen. Get the remainder. Of course, we have 18. So the next thing that we're going to come down and check would be the next highest number, which are our dimes. So we're going to take D, set that equal to R divided by 10. Keeping in mind, once again, we want the integer. So when I do that and then check D, you can see we have 1 dime. Makes sense. That takes us up to $4.35. Now we have to reduce R, so we're going to set R equals, and of course we're going to grab the current value of R, which is 18. So R modulo 10. So we're basically doing this thing, but we're getting the remainder. So now if we do that, and we check R, of course there's 8 left over, because we got rid of 10 of it. Now we want to go to nickels. So N is going to equal, just like up here, R divided by, and how much is a nickel worth? 5. Alright, just like that. And if we check nickels, we have 1. Alright, so let's go ahead and finish up now. We have to rerun this. R equals R modulo, but now we're doing modulo 5. And by running that, we're taking 8 divided by 5, getting the remainder. So if we check R now, there should be 3 left over, and there is. And of course, we could just take R and say that's how many pennies we got left. Or we could go in and actually do the same thing up here and set P equal to R divided by 1. And if we run that and check P, of course we have 3. So let's go ahead and clear this screen. And if we check our quarters, dimes, nickels, and pennies, and of course we take our money, alright, because that should be the same. So we had 443, or $4.43, gives us 17 quarters, 1 dime, 1 nickel, and 3 pennies. And if you run those calculations and count out that many of each of those, you'll come up with $4.43. So that's just one of the ways that modulo can be useful. So let me go ahead and clear this screen. And our next one is going to be on exponents. Now this is when you raise something to the third power. Or not to the third power, but to any power. So if I was to take, say, 5 to the second power. Alright, that would be 5 and then a little 2 up here. And what that means is 5 times 5. So the way they do it mathematically in computer science is 2 asterisks or the shift 8 key. And if you run that, you should get 25. Now if I do it to the third power, then I should get 125, because that would be like saying 5 times 5, which is 25, times 5. So if you took 25 and multiplied that by 5, you would get 125. So that's the way that that works. So hopefully what we've covered here in the arithmetic operators isn't too confusing. I've not really used the exponents, but if you were going to build some type of math problem, I'm sure you would. Or, you know, some big calculations, but yeah, you'll use probably your addition, subtraction, multiplication, division, and of course modulo. Modulo seems to be the one that you use a lot. And when you see some of these upcoming problems that we're going to have down the road, and the way we use modulo to solve the problem, you're going to see just how important that one is. Alright, so one of the last things that I want to cover is order of operations. So let me go ahead and clear the screen once again. Alright, so I remember order of operations as a kid. Of course, they called it Pemdas when they were teaching me. And I lost track of it somewhere over the years. That's why I think it's very important to cover it again, because it's the way we do math. And if you don't follow this order of operations, you're going to wind up with wrong answers. So what does PEMDAS stand for? Parentheses, exponents, multiplication, division, arithmetic, and subtraction, or adding and subtraction. Alright, so here's the rules. If grouping symbols are used such as parentheses, you perform the operations inside the grouping symbols first. Then, once you've done that, so if there's parentheses in your problem, you solve that first. Then you evaluate any expression with exponent. And exponents are what we just talked about, where you raise something to a certain power. So that's the next thing that you do. Then you multiply and divide from left to right. So those are equal. So if you have a division or multiplication, you start just like you read from left to right, and you cover those problems in order. Then you go back and you add and subtract, and they're even as well, doing the same thing. You go back to the left and you do all the addition and subtraction in order. So I don't mean to, talk down, but once again, I actually had an issue with this. And I'd forgotten it for a lot of years until it was reintroduced to me around the age of 50 when I went to college. So what does that mean? So a simple problem is if we took 4 plus 6 times 10. So now if you looked at this and you just did it the way I've probably did it over the years and said 4 plus 6 is 10, and you multiply that by 10, you should have 100. But of course, if you follow the order of operations that we just looked at, remember, okay, we don't have any parentheses, we don't have any exponents. So the next thing that we have to look at is multiplication and division, starting from this end, working our way over. Here's a multiplication problem. So 6 times 10 is 60. Okay, we're at the end. Then we come back over and we come in and we add that 60 to 4. So this will be 64. All right, but how do we get the answer that I wanted, or that I thought I should have had, which is 100? Well, the way you do that is you just wrap these in parentheses. All right, and by doing that, now you're forced to do this problem first. So 4 plus 6 is 10. Then you multiply that by 10, and you'll get 100. So hopefully this makes sense. Order of operations are very important. And we're going to go ahead and end here because these are all the mathematical operators. Once again, addition, subtraction, multiplication, division. We got 2 types of divisions in there. You got one that's going to return a decimal or a float. And then you have one that will return an integer. Then you have modulo, which gets you the remainder of the division problem. You have exponents. And then, of course, when you're writing out lengthy things, and you'll also see this in some of your code that you're going to be doing when you're doing condition statements, sometimes you have to group things so that you don't confuse the computer. So that's it for now, and we'll cover some more operators in the next few videos. Thanks for watching.